не понимает по-русски? Okay. Do we have guests who speak English? No? Okay, so sadly, organizer asked me to speak in English. So you're Russian, but you will be really English. I don't prepare my talk, so it will be like a presentation. So you're welcome to stop me in the middle and ask any questions. So the second half of my talk is just programming, so we'll go through the code base and I will show you how it works. So let me introduce myself. I'm Niquola Ryzhikov, CTO of Health Samurai. So we've been doing health IT for more than a decade. And we are building like a backend as a service to build healthcare application. So the topic of my talk is building user. Okay. There is a problem with it. Может по-русски дальше. Вообще ничего не слышно, да? Ну садитесь ближе, может быть. Нас мало, на самом деле. Идите ближе. А еще и порисовать можно. Вообще не слышно? Он просто может завестись, поэтому ребята боятся включать.
Скорее даже не слышно, у нас неравномерный голос.
Неравномерный голос. Okay. Who can hear me now? Okay, there is some echo. Do you hear echo? No? Only me? Let's go. So the topic of my talk is how we're doing the user interfaces. Looks like making the user interface for like a business application is a typical job. So you're doing it for every application, and it's a routine task. You should be doing more than 10 years. And there is a problem. We can expect that during this time we can find an elegant and simple solution to make efficiently user interfaces. But I don't know, I think we have a problem. So who think that the current state of building user interfaces is satisfiable? Is good? Who can build user? Okay, the one couple of guys. Yeah. But my opinion, that what I see around me, so we've got usually more than half of our business application is a user interface. I mean the logic, the code base, and it got the complex piece of software, as well as fragile, it's breaking all the time. It's very expensive and inefficient to build it, so it's usually not covered by tests. Yes, who have tests for the user interface? Who really have tests for the user interface? Okay, not for the company. There are some guys, but not all. There's a small history of, so I started working on web development more than a decade ago, like 15 years ago. So I have a long history making like web user interfaces. Initially it was like vanilla JS. There was no libraries in open source. And some iframes was a free one. Then maybe like 15 years ago, we started building so-called single-page applications. At that time, they called it rich internet application. There was no term single-page application. So we worked with the .Geo framework, and we followed like Google guys who built this first application, Gmail, which was the first single-page application. So everybody tried to do this. So we start building it, we create all these components, and this was a system of widgets. It was quite nice. So, and for when we were working on the read-only interfaces, everything was smooth. When we go and start making the real system, like real EHR system, healthcare record system, so we got the problems. Only the very experienced engineer was able to make the changes. And we slowed down the development really a lot. So then we tried to switch back to the Rails way. So at that time we were working on Ruby on Rails. We started doing the classical Web 0.20 development. And bam, so we got like 1 order of magnitude improvement in the performance of programmers. Even the middle engineer was able to complete the feature in a couple of days. So can you do it now? Like do the CRUD feature in a couple of days with all the tests and all the stuff using the current state of building application? I think no. Let's say it. And then we got the Angular, which was kind of good stuff. It was easy to learn. So even not developers was able to build user interface, and then we got React and all this component stuff, and again, it's getting more and more complicated. So, and the last, I think, position in our list now is reframe plus reagent plus Clojure script, and some way inside the React. We don't like React a lot. So what the problem with the user interfaces? So when we do this in a web point to zero way, so we just render page on the backend. Yes, we get the request, we go to the database, and we apply the templating to the data which we got from the database, and return the new page. It was very easy, like a mental model, easy to write, easy to test. That's why it was so efficient to build this web point to zero application. And now we have like a REST API or GraphQL API, and a single page application or mobile application. And to be honest, this is distributed system. And if you know the first rule of distributed system, who knows the first rule of distributed system?
Don't build distributed system.
Yes, just don't build it. But we are building. So to be honest, the user interface, like single page application, is a distributed system. So it's asynchronous. Every request can break. You have to, I don't know, make some contract between the front end and the back end. Yes, so it's really a distributed system, one order of magnitude more complicated to build. So that's probably why the problem, and all these hype technologies which we hear now, like React, TypeScript, and Babel, Webpack, I don't know, they do not introduce any simplicity, any solution to the problem. So just maybe 1 month ago, I was in New York and consulted some project, and guys have 1 million of dependency in a Node.js project. Just think about 1 million dependencies. It's not operating system, it's just a web application to, I don't know, connect the physician and patients. So, as well, everybody is talking about components. Components save the world. No. That's completely not true. So we have a history of user interface. We already have all these widgets and components 20 years ago. And a Delphi, I don't know, in Visual Basic, and this component doesn't save the world. So you got this component head. This is mutable state, which is distributed over the application. This is like a dynamic network of objects which interact with each other, burn the new, die, and always leaking abstraction. People believe that they can build a reusable component which they can use again and again, but that's not true. It's usually at the start. You start using some component, you put like a calendar on your application, and you enjoy. So you did the job in 5 minutes, but then you understand that you have requirements to show only specific days, to highlight some stuff, and then the properties of this component is not enough, so you go inside this component, we write this component multiple times. So we build a lot of systems, and all of the systems end up with a custom library of widgets. So I never seen that, maybe only for very simple application, that you can really reuse some external components. So the components is not a solution, and it's this old object-oriented hell which we already know. It's a zero architecture, no constraints. It's very complicated to reason, so that's the problem. And this is user interface. Yes, and this is the half of our system. It's not covered by tests. It's hard to reason, so the problem is not yet solved. Can we handle it? So that's the topic of my talk. So we were looking for the solution of this problem. The one solution, just don't do the user interfaces this way. Just go back to the web point to zero. I'm not joking. There's a rising new frameworks which are trying to build UI on the back end. This is confident, runtime, you control everything, no any problems. There is some technical problems how to make it work, but I think it's probably the next generation framework will be in this field. But okay, let's start from the very simple stuff. How we test and how we organize the user interface to make it testable. Yes, you know, code can be testable or not testable. And sometimes you have to design the code so this code can be testable. So, and here comes the reframe. Who is using reframe on daily jobs? Okay, so nice. You know how reframe works. So reframes make a very good separation of concerns. So we have event handler, which is handled some even from user interface, which emits the effect, some dirty stuff like sending XHR request or saving cookies or reading cookies. And then we can store it in the centralized database. This is the only place where we put the mutable state. And this is proven solution because on the backend side, we are okay. We have one database. We put all the data into one database. This is one big global mutable variable. But we have very nice protocol like SQL, for example, and some transaction guarantees. So we are okay with this. I think that have all this data in one place is better than have it through all the system. So we have this database, and then we have reactive subscriptions, which deduce some new data from the databases, as well as the pure function. And then we just can bind it to some React components, so when the database change, the subscription change, and the component is rewritten. Yes? That's how reframe works. It usually looks like this. What's nice about the reframe? Oh, maybe I have to switch to the code. So let's say we want to build a very simple counter. Yes, demonstrate how reframe works. So reframe. Can you see the code? I can increase it. Yes. Can you see it? Okay. So let's say we have even somebody clicked the button. So, and we have event handler, which is called user event, which is like getting this event and go to the database and update the counter key in a hash map and just increase it. Yes? So this is event handler. If you look precisely at this function, which is a completely pure function. Yes? So this file is written in Clojure C. So it's just a Clojure which can be shared between the browser and the backend. Now I'm on Junior level, so I can run this function. So I run this function, and I can just call this function. Yes. And in terms of reframe, we're passing the old database and we're getting the new database. Then reframe will wrap it into some reactive atom and blah blah blah. And then we have the subscription, which is a function from database, which is a function which is passed the database and return us some data structure. So again, it's a completely pure function. So we can call it. And it's not just pure in terms of functional programming, as well as pure that it doesn't have any connection to JavaScript, to browser, to element, to DOM, even to virtual DOM, to anything. It's just a pure Clojure code. And this is very nice. This is what reframe gave us. It separated concerns. It gave us a place to put the logic in a pure place, which can be shared between the backend and the frontend. And this is very important for our future. So then we have to follow the reframe convention and register this function, event handler, and register the subscription. Then we can go and write some almost, you don't see React here, yes? So we just see the templating. So we have a button, and we dispatch the click event on this button, and we subscribe it to the counter model, and we display the results. So we can go and try this. But what nice, it's very simple stuff. We'll go more complicated, but this is pure. This is functional. We can write tests for this function. Okay, and we can run these functions on the GVM because it's Clojure. Let's go further. What can we do? So let's say, so the general idea, maybe I can explain it right now, is very simple. Yeah, the very important moment is a subscription. Yeah, the subscription is a function which is passed to the database and returns something. So the idea that we can push a lot of logic inside subscription, if we think about subscription like a view model. If you ever read like Martin Fowler article, which is called UI architecture, this is a peak of UI architecture when you have this view model. This is logical representation of your view, which is not connected to any components, any rendering stuff. So, and the idea that you can use the reframe subscription as a view model. So try to make as as much logic as possible in a subscription, not in a component. Then the component can be very stupid stuff, which is just render the view model. So and the view model is a pure Clojure data structure and functions, and it can be tested. So this is the second idea after the reframe, when we introduce this view model idea and make the view model the reframe subscription, we're able to push a lot of logic into this pure layer. Is it clear? Okay. So let's go further. So usually, we introduce some conventions. When we use a reframe, we say in your application you have like pages. So it's some specific screens for users, so user can do some job which you need. So and then we introduce a convention that we have the one event when you open this page with navigation, and it's represented as a keyword in the database. As well, we have one subscription for this page, which is returns the view model for this page. It's a simple convention. It doesn't work all the time, but most of the time it works. That's how we start like virtualizing our user interface. So we say we have a page, we have a page event, we have a page subscription, which represents the view model of this page. Okay? Got it? So then we have like a simple routing. Never do routing in the components. It's completely stupid. It's completely pure stuff. You're passing the URL and you're getting the handler. So it's just a pure function. And then some way you can connect this routing function to changes in browser location and call and render component you need and call the controller behind this component you need. So for example, I forgot to say that this project is on GitHub, so you can get this project and play with it. It's called Clojure.ru on my GitHub. Yeah, so, are you with me? So, we have a routing function which is emitting this event. The user opened the page. So we as well introduce a couple of phases for this event. So when the page is opened, so it's opened with a phase init. When the params changed, sometimes you want to update params, so you can remember this URL and send somebody or refresh the page. So when params change, you don't need to re-render all and get all the data from the backend. So that's why we introduced it as a separate phase. And when the user leaving the page, so we emit event in the phase like day needs. We are leaving page. Probably your controller will clean up some resources, some database, something else. Okay. So that's how we model the page. We can register it. So if we go to this page, refresh it. For example, we don't see, but I'm adding some parameter like we have another. Yes. So now let's think. So we have this place in the reframe architecture where we can put the logic as a completely pure Clojure stuff. As well, we have a backend which is written in Clojure. And we are very comfortable to writing the functional test on the backend. Yes? Probably everybody do this, the functional test. I think it's most valuable test, or at least for business applications. So because it's not have a lot of connection and coupling with implementation, but it's really track the business function of your application. So let's switch back to our backend code. And in our backend code, we usually use something like ring or get install, it doesn't matter. So our handlers is the functions which return the hash map with a response. Yes, and usually we do like this. So we have some middleware which are parsing the HTTP request, and then we have some dispatch function which decide which controller we have to call to handle this request, like routing stuff. And then we call this function. It returns the hash map, and then this middleware converted back to the HTTP stream for response. So the logical part of our application is behind the dispatch. It started from dispatch. We're sending the hash map, and we're getting back hash map. So this idea was stolen from Ruby on Rails when you write tests without handling all this HTTP parsing stuff, just by calling dispatch directly. Yes, that's how we can do the functional test on the backend. So we have a function. This is our handlers, and somewhere, this is a handler for the web server, which is getting request. This handler is looking through the routing, metadata, finding the handler, another function which it should call, and just call it. Passing, we call it context idea, and you have a database connection in this context, and blah, blah, blah. So, and this handler, this dispatch function with remember the context, we can call it like a dispatch. And let's go. So when we start the application, we start the context, open connection to the database like this, so we have a database, and then we have this dispatch function. So we are passing like a ring request, calling this function and getting the response. Nice. So it's not pure function, but it's still function, which can be easily called in a. So for example, for the tests, we can create like a separate database, create connection to this database. It's all stuff like AWT system. This is in this repository. Then we can like start this stuff, which open connection creates a context and provide us this dispatch function. And we have a nice function which is a helper, which is called match. So it's getting the request hash map, calling the dispatch function on the backend, and then trying to match the response against this pattern. It's like pattern matching. Yes, so we can call it, and we see, we can run this test. If we are looking for unexisting URL, it's returning 404. So as well, we can, in this system namespace, which is represent like a system which we don't write test again, so like a black box. Yes, so we have this dispatch stuff. So we can put some helpers like truncate the table, they create a couple of resources, and then try to call something and match it together. So this is very easy to write this test, yes? Got it? So we have this stateful, but still nice function which we call dispatch, which is really calling the system, calling the database, and we can match the result of the response, which is represented as a ring response. That's usually how we do functional testing on the backend. It's really easy to do. We call it second time, so we have like unique ID restrictions. So it's easy to write, you can iterate, you can use REPL. So this is another part, and now let's try to connect it. So if we look into the reframe architecture, so all the dirty stuff is done by this effect. And there is not so much effects, usually it's like a few, less than 10. You're doing XHR, you're storing some cookies, some local storage. It's really enumerated, yes? And other part, which is the red one, is a pure Clojure. We can just take this stuff and move to the backend. And if we really designed our application that way, that we push it as much logic as we can into this pure len, we can move this pure len into the JVM. And what is waiting us on the JVM side? So we already seen this functional test, which is easy to write, easy to create the environment, like empty table, load some fixtures, create some situation, reproduce some bugs. And this test are cheap. And when we're moving this reframe part to the backend, we got the cheap UI test. They don't test all this stuff, they don't test the components, but because we move most of the logic to this, they still test a lot. And let's go and see some real stuff. So in this application, maybe I can speak a little bit about the structure. Here is a back folder, which is a source for the backend. There is a front folder, which is a source code for the front end. Use the same repo to start everything. I built it one day, so you're welcome to me now. So let's go here. Try to understand what's going on. This is a simple grid. I can show you how it works, so you just understand. So if you go here, we got the list from the database, and we can search for this. This is simple grid. This is read-only stuff. It's a full step. So let's try to read this code. So we have a page which we call the welcome.sp. So this page, when it's opened by the router, calling this event handler, which we call index, and face init. We are emitting the effect, which is saying go to the backend and try to get the camps. And when everything is okay, call another event loaded with the data from the response. If something went wrong, so call the fail event. Okay, so the load is kind of simple, so it's called by the effect when everything is okay. So we get this event and the data and put the data under this page key into our centralized database. Yes? So we fail it, so we just change the status. And we have the page subscription, which is, as we said, it's a view model. So you probably can guess what will be shown on the user interface if you read this stuff. And it's very important to do as much logic as possible in the view model, like building references, I don't know, creating the classes, like it's active, not active stuff. So because, this is the land of pure Clojure. So, when people trying to search, we have this handler, event handler, which doing the same request just with a parameter. Yes, all the same. So that's all. And let's see how we can test it when we connected these features of functional test on the backend with a pure part of the reframe. So we can start our application, open the connection, so we can truncate the table to reproduce the situation when we have nothing in a table. So then there is some helper, we just reset this reframe atom database in empty state, and then we call the helper which say reopen, like we opening the root of our application, but essentially it's just dispatching this event. So if you have a pure routing function, you can easily implement this sugar, which is like simulating the browser behavior. We just open the root page, yes? So, and we can run it one by one. So let's say we truncated the camps, we reset the application, we reopen the state, and we can look into our reframe database internals, what's going on. We can subscribe to the page view model. We can look into this page view model, it's empty. And we can write like a matching criteria, and this is assertion that we have this message with nothing. Then we can create a couple of camps like this, and then say reopen. So just let's look into the page. Yeah, we see there's a grid with some items, there's a shrefs build it so we can get a cert. It's working. So we can dispatch the function like we are searching some term, and we can look and assert about the page state again. So it's easy, and this is function to test the REST API. If we're not sure what's going on inside, we see the result. And then we can go to another page and blah blah blah. And I can run this test, and you see it's great. It's really cheap to write. You're gonna enjoy it. It's much more easy to create the environment which you needed to build the user interface. Just compare how you usually build the user interface. You open the browser, I know you create some stuff. I know somehow, if you're a good Clojure developer, probably you open the repo and empty the table, then you see this message nothing, then create some stuff, you see, then create more stuff, you see the testing the paging and all that. So you don't need to do it manually once and once again. You can replace it with this cheap tests, functional tests. They're really efficient to run. So that's the idea. If you have questions, I can explain. Yeah.
As far as I can understand, you use Clojure C like everywhere, right?
Not everywhere. Yeah, we use Clojure C for the model layer. So if we go to the view layer, it's here. So here we require the model, which is written in Clojure C, and we write this React component. Here we bind the search with the search event emission. Here we show the message from our model. Here we subscribe to our view model, and here we draw our view. Yeah.
But you can use the Clojure script files from.
But this is Clojure script. This is Clojure C. And if you go to the test, so it's written in Clojure, so it's a completely JVM stuff, but it requires the same Clojure C file. So that's the idea.
Yeah, it's just the thing that I've tried this in beta testing, but it turns out some library doesn't provide Clojure C files for.
Let's throw it away and write your own. Take it back to home. Yeah, the reframe guys did a great job. So they written most of the code in Clojure C. As well, we do some convenient fixes for reframe. So for example, we turn off asynchronous reframe because it's much more easier to write tests on the backend when you synchronous. And usually your handlers of REST API are synchronous, so it's really much more easier. But we just patch a little bit the reframe, so it's becoming synchronous on the backend. It's still asynchronous on the front.
Thank you.
So I have a question too. So since you are including Clojure C files, does that mean that you are loading up your jar file with client logic?
No.
So you are excluding that from the
I can show you.
stage.
So here are the two source folders. One is a back, which is a backend code,
Okay.
and one is a front. And this Clojure C files living in a front folder. And we have dev.cdm, which is front and which is back. When you're building the back, you just do not include the front and the test folder. But the tests for this stuff is in the same test folder. And they are on the JVM stuff.
Thanks.
Okay. How much time?
May I ask one more
10 minutes?
question?
Okay, yeah.
Do you provide some sandbox as a backend, or it is a fully fledged with all the backend logic and stuff? Do you write end-to-end test or just the front?
It's a functional test. They calling your event handler on the JVM, the event handler calling the sending XHR effect. Then we have on JVM side we have implementation of this effect. Yeah, I forgot to say for the XHR effect. We just rewritten it to call directly our dispatch function.
So you mock it.
It's not mocked. Yeah, it's just another implementation because it's really calling the dispatch function. And dispatch function really calling the handler of REST event, and it's calling the database, getting the data. So we're testing really the whole stack.
Okay.
Upside down. Yeah. So there's another topic when we're talking about this. It's a forms. It's another pain today for front-end developers. You got this basic idea that we're trying to do as much logic on our model through our Clojure layer as possible. But when we got to the forms, you think I usually use some rich components for the forms, which take a lot of logic. Yes. So there is a lot of logic in the components, and nobody tried to separate the model of the form component, form widget input, from the presentation. Usually it's just one messy JavaScript React component or even worse. So then when you try to do the same approach with the forms, you have to rethink how forms work. The general idea, you have to do the same separation in the form model, so you have to have the form model with all the validation on the form model side without touching to the components. So it's little bit, how to say, непривычно. Unusual, yeah, for the people. So we have a library which is called ZenForm. It has some component, some widgets, but I recommend to throw it away. It just have the idea, the convention, how you can model form on a backend, on a model side. So let's see. So here is the logic. So you can go, create a new. You see the validations here, they are working. This is working. It's working. Savings, weddings, this stretch stuff. That's how it works. And here is a model. So we have a metadata for the form, which describes the form and the validators. Because if you want to push this logic on a model side, you should not go to the component and say on the component side that this field is required. Yes. So you have to say the field is required on the model layer. So this ZenForm library provides like a multi-method just to call for this stuff. And then you have to init the form, like here. Essentially, the form is a small application, a small world with some conventions. If you think about how to model the form, you have a widget, usually with an input. As well, you have errors for this widget. As well, you have the flag, which is like dirty, not dirty, touch it, not touch it. So we model the form as a tree of nodes with all these components. We have cursors to efficiently subscribe to specific node. And then you can attach the specialized widget to this node. So let me show how it's attached. For example, here, the sample text input. So we provide like subscription. So we are operating by the path. So we store all the form state in a centralized database. No local state in the components. It's kind of unusual. So that's why when you're working with our form model, you're usually operating by the path. It's like cursor where the form is placed. There is a path to the form object, and there is a path to the specific element inside the form. So here you can subscribe to the form node, which will contain all the errors, flags, and the data. So that means that we put the form state not as a value object, as we got that. We get in the user, and then we split it and put into this form nodes. And then when you submit, we have to collect it back. Okay, you will have some time, it's open source, to play with it. And that's how you can bind it to some real components. So you subscribe to the node, then you have to provide the onChange event and send the event set value with all the passes, and then all the magic happens on the ZenForm engine. It will mark it as a dirty, try to run all the validators, put the errors into this form node, and all this stuff. Okay. Do you have questions about form? I think it's worth a separate talk. I'm talking about forms. So, and I think I finished. So we use this approach for like some number of projects. It's proved to work. So the developers reported the feeling of the front-end code is the same like the back-end code. It's kind of the same size, the same level of confidentiality about this code. So, yeah, it works. You're welcome with ideas on open source and some implementation on open source. It's not yet perfect. I think we can make it better together. Thank you.
So it's done. Thank you. Some questions, Nikolay?
What is the GitHub name?
Yeah, let me show you. It's a GitHub.
Okay. While Nikolay is searching more questions.
Hello. First of all, thank you very much for the great talk. Really enjoyed it.
This is a
You've mentioned briefly that you use React, both React and Clojure for the project. So I was wondering, everything you've mentioned sounds great, but you can do it in React pretty easily now. There are plenty of libraries like Redux or MobX that do the same thing, and you can write your components no problem. So basically, what I'm asking is, in your experience, which parts of your project, or maybe projects, suit React better, and which parts of your project suit Clojure with reagent, reframe, and so on better? So what are the trade-offs in your experience? Thank you.
Yeah, thank you for the question. I hate React. It's a component approach which doesn't work, really doesn't work. So the only thing which is valuable about React, they introduced this render function with a virtual DOM, which give us solution like we're rendering template on the backend. This is the only useful stuff. All these games with the components, it's a hell. So you got the same, like Martin Fowler called it form and controls approach. When your application is just a form and controls, and all the logic, I don't know, like shattered around all these components. So that's usually how you got the React application. Yes, you can apply this approach to JavaScript code, because if you have a Node.js on the backend, and if you have a React with some nice libraries like Reframe, it can be Redux plus Saga plus something else. So because Redux usually doesn't provide you a lot of value, it's just, I don't know, a lot of code to write. There is no effects in React, there is no subscription in React. So just say you're working with the events, and it's kind of dirty code. It's calling XHR and so stuff. So, but you can apply the same approach if you introduce like Elm architecture, this reframe architecture, and use it on the backend side. So, and I prefer do not see React at all. So I only go to the React world when I need some very complicated component, like integrating some IDE widget, like Clojure or something like this inside my application. Then I have to go inside. But if we look into the code, our code, let's say, there is no React. It's hidden, yes. You understand that this is React components, but it looks like template. So I prefer to see template. And React now has a component like pure function. Yeah, I think the ideal component is pure function. When you start working with all the state, there is no solution. So you will fight again and again, you will get the messy code. That's my opinion. Don't use React.
Thank you for the talk. I wanted to ask about what do you think about Clojure, which seems to solve a lot of hassle, which require probably isn't so suited. It includes server-side rendering, and it seems like it'd be even easier to write server tests in Clojure.
Yeah, that's okay about what was the name of library?
Falcon.
Falcon. I know only one Falcon, which is a replacement. Huh? Fulcrum. Okay. So you've never seen it? Yeah. Again, I don't think that backend rendering is the same what I'm talking about. So I don't want to see the components at all. Yes. I mean, I have a business logic, and I want to test it. And I want to remove all this rendering stuff from my business logic. I and separate the stuff and test it. So that's the first idea. There are some libraries I've heard which are trying to do as much as possible on the backend, like sending just a patch to the front end and applying on the user side. So on the user side you only have the patcher, and all the state is on the server side. That's interesting, promising approach. The problem is it doesn't scale very well because it has a session affinity, so you have to connect the user to the specific server. It's not easy to restart, so you have to keep all this stuff in memory or some database in memory. But this can be solved, but then, so if we think about like interactive application when we have multiple users, so they still need this connection, and it would be nice to have the logic on the back end. But let's see what's happening. Probably I'm not answering the question, but